now we are going into the skies and we are heading into a quite a different field of application. We're going into the aviation sector with a company called Pipistrel, and we have here online with us a propulsion engineer of this company based in Slovenia, Pedro Garcia Gonzalez, and he's going to present to us what the company does in terms of using hydrogen as a source of energy for electric propulsion in aviation. And last year in 2023, there was also the first flight of this kind carried out by this company. So we are looking forward to your presentation, Mr. Gonzalez.
Hello, everyone. Good afternoon. Can you hear me?
Yes.
Perfect. Thank you. So thank you for the introduction. As mentioned, my name is Pedro Garcia. I am working as lead propulsion research engineer at Pipistrel. And I have prepared this presentation, which is mainly focused on the on our research activities related to hydrogen for aviation. For those who maybe don't know the company, Pipistrel is a general aviation aircraft manufacturer established more than 30 years ago in Slovenia, which is worldwide renowned currently for the first and for the time being only EASA type certified electric aircraft in the market, the Pipistrel Vertical, which is currently being used mainly for flight training with this type of electric aircraft. If you can go to the next slide. Pipistrel is currently heavily involved in several European funded projects on hydrogen-powered aviation. In the past, we have been involved in the MAHEPA project, in which 2 aircraft demonstrators were developed. The first was the Pantera in the hybrid electric powertrain architecture, and the second one to the right is the modification to the Pipistrel WC4 aircraft called the Hy4 for integration of fuel cells and gaseous hydrogen. This aircraft was the powertrain of this aircraft was modified, and then the aircraft was flight tested as part of the MAHEPA project. In this case, having gaseous hydrogen tanks and a fuel cell powertrain located in the middle of the middle nacelle that you can see in the image. And in this project, we were able to successfully flight test this twin fuselage aircraft. If you can go to the next slide. As currently mentioned, in the last year, the HEVEN project was a continuation of MAHEPA related to the modification of this aircraft for integration of a liquid hydrogen storage and distribution system in collaboration with partners such as H2Fly and Air Liquide. So in this project, we had the responsibility to assist with the integration of the liquid hydrogen storage system and to lead the flight test campaign, which was performed in Maribor, Slovenia in September of 2023. And the project, after, of course, challenges related to the novelty of the technology and the needs for integration, successfully achieved the world's first flight test of an aircraft powered by liquid hydrogen and fuel cells, achieving a range of 1,500 kilometers in one of the test flights, which is a substantial increase compared to the gaseous hydrogen storage. The transition from gaseous hydrogen to liquid hydrogen is proved to be challenging, but finally the project proved to be a success. And as outcomes from this project, we have the risking of the technologies for liquid hydrogen storage for aircraft and for distribution of this fuel to the fuel cells. And also it serves, as previously indicated, to increase the social acceptance of this kind of technology, serving as a demonstrator that shows to people that hydrogen-powered flights will be safe. If you can go to the next slide. So the type of aircraft concepts that we are moving towards with the development of hydrogen technologies for aircraft is include, for example, the 19-seater concept that we studied in the Unifier 19 EU-funded project. In this EU-funded project, we worked on the development of a 90-seater aircraft, which would be capable of connecting villages and locations that are not well connected by ground infrastructure currently, via a set of 90-seater aircraft capable of taking off and landing in short grass runways that are close to villages, such as, for example, the airfield in China, where Pipistrel is located, which would be able to operate with low noise so that the nuisance to the close settlements is minimal, and that is also capable of performing several missions without refueling to be able to adapt to the limitations in terms of infrastructure in the initial years. So as a result of this project, we have a conceptual and preliminary design of a 90-seater aircraft powered by liquid hydrogen and fuel cells that can operate in several airfields, and in the small airfields, both being capable of transporting people from one small airfield to other small airfield in what we call a mini-liner fashion, but also to transport people from small airfields to hubs in order to increase the connectivity in regions of Europe in which the ground infrastructure is not so well developed. To the right, you can see an example of a market study that was performed for the Venice airport, and there is extensive documentation online on this project. Currently, we are involved in several other research projects in which we are trying to develop ground demonstrators for the building blocks for this aircraft technology, such as, for example, fuel cell powertrains. We are currently involved in the newborn EU-funded project in which we will be developing a ground demonstrator for a fuel cell powertrain. Also,